With that, let's get to the topic for today. I'm happy to have, I think, Marco and I think Guillermo will join us also. I know that Tim is busy, but those of us who've been in Nicosia probably have seen and know these people, if not by, seen them in present and maybe by reading some of the books or some of the reports. And talking about books, here's the latest one that I guess will be the focus for today's presentation. Over the last 20 years, I guess model-based has really been much in the focus. Also, I've seen the Nicosia and the system engineering discipline move away from, talking about single type of systems to family of systems, and product lines is really, well, we'll get to know more about that today. So just to start with Tim, who's not present, he's a very active presenter, but also a leader in the SysML, the language. So he's a consultant at OOSE in Germany, but very active in the committees that are establishing the next version now, the SysML v2, for example. Hugo, are you with us? No, he seems like he's leaving this to Marco today. But Hugo Guillermo Gongora, he's head of the product lines and then the multidisciplinary analysis optimization at Airbus. He has a long experience within SE and MBSC. So in different industries, I guess I've known him since he worked with railways, and he also started the automotive working group within Nicosia, and also is a founder of the PLE working group. Which brings us to Marco, who's is the chair for this product line engineering working group within Nicosia. He's also senior director for solutions engineering at PTC, and probably most of you have known PTC as one of the leading providers of PLM systems, PLE systems, and he has a long experience in this. And I think I actually worked also for Airbus previously, but now he's here to give us their thoughts and theories and practices within product line engineering. So Marco, please take it away from here.
Yes.
I need
thank you for
stop sharing.
Thank you for inviting me. And we plan to have Guillermo here. I think he had an important last minute thing. So I also got notified very late about it. But I hope my presentation will be enough. And by the way, I'm the leading author of the book. That's why I think I can say something about it. And of course, it would have been better to have Tim Guillermo as well, but it's always very hard to get our schedule working, and we have never done one presentation all three together so far, unfortunately. Okay, you need to stop sharing for me to share so that I can. Very good, thank you. And so let's start. We are gonna start with. I ask if you can see my screen.
Yes.
You see the small or the big? Present.
We see the presentation, the presenter's view, so maybe you should swap.
Okay, now you should see the other one, right? Okay. So let me start. The book, so the webinar follows the structure of the book. And to simplify it, of course, we cannot say we cannot cover the entire content of the book, but the idea is really to give an overview what the topic is about, what is model-based product line engineering, and that's what we would like to do today. So we start with an introduction, then we have like a motivation and of PLE, because everything starts with a motivation. Otherwise, you are not gonna implement anything if you don't have a strong motivation. Then after you have the motivation, you need a foundation, because you need to know what it is and why it's important and for your organization. and then you start implementing maybe starting with a POC in a team, in a department of the company, and finally you can roll it out and scale it once you start to have success on the first implementation. And of course, for us, there was no book on product line engineering. By the way, this is the first book on product line engineering after 24 years. The only probably source that we have, it was for software product lines, written by Paul Clements and Linda Northrop from Carnegie Mellon University in 2001. So it's almost 25 years that we didn't have any source on PLE. And as I said, this includes also systems, mainly focused on systems engineering, not just on software development. And that's why we thought that we wanted to have practical cases as well at the end, concrete cases to show how companies are adopting it, to show the commonalities and the differences. So let me, we already introduced ourselves. I will not say, I think the introduction was very good and I'm not gonna repeat. And that's why I'm starting first with the presentation. And I want to start with this sentence. Sorry, I think it remained the logo of the previous presentation. You can see it was Aise, so the Italian one. So I will send them the slides without let me remove it quickly because I don't disturbs me. Sorry, I thought I removed it, but apparently I didn't. Okay, I will stay with the logo today. Sorry for that. I will send the presentation then without. So the key question is no organization builds just one.
Marco, you need to swap views
Yeah.
again. And the rest of us mute, please.
Yes. So the question is no organization builds just one. And that's what is the key motivation of the book and the key motivation of product line engineering or model-based product line engineering. In fact, if you build just one product independently in the industry where you are, so aerospace, defense, aviation, B2B, so vacuum cleaners development, trains development, automotive development, and industrial systems, independently on which organization you are, if you build just one product, probably either you build a commodity, so the difference is only based on price, or you will be soon out of the market. There are very few cases with very big, large infrastructure projects where the organization is just built for that specific project, and a project that lasts 20, 30 years, probably in that specific case, you build just that. We're thinking about airports, this type of big, as an example. But even in that case, you have possibility to reuse and apply PLE. Now, that lead us to write a book. And as I mentioned, the book has 5 cases from 5 companies. Today, we'll quickly look at 2 of them. That will be Airbus, MBDA, but we also have, sorry, it will be Airbus and Thales, but we also have MBDA, Raytheon, and Belimo that show with some differences, however, sharing some commonalities, how the PLE and MBPLE can be implemented efficiently and effectively. If you can mute yourself, would be great. Yeah, so let's start with the motivation. I was working for Airbus before, and when I was working for Airbus, I had to explain to people that didn't have any idea what is model-based product line engineering and what is product line engineering and why you need it. So then you may think that Airbus is using very complex example because everybody is a super skilled and expert in the aviation system development. Well, it was not the case because you have to deal with several people that have only taken a plane, as a tourist or as a passenger, and because probably they belong to the process part or the method parts and the tools or the procurement or human resources and so on and so forth. That's why you need to find a way to explain this to everybody within the organization in a way that everybody can have at least a level of understanding that can, with the time, increase depending on the role and the activities that the person will have to perform and related to PLE. That's why I was using a Disney example. And this led me also to people were in the organization at Airbus were calling me Mr. Disney. I was like a kind of, okay, fine. If it helps the cause, I'm happy with it. And then I want to start this video now, and you will see probably why I am referring to it. So here you can see two different products. We can see two different stakeholders. Probably you have like two target customers. So two different generation of kids, not only kids, also adults. And we can see that the reusability, the reuse is quite impressive, not only in terms of the scenery, but also the animation itself, so the behavior of the scene. And even if they look completely two different products, and if you have watched in the past those movies, probably you have not realized this. And at the same time, there is a big reuse among them. Then you may think, okay, this is probably a reuse that happened once by accident. But if I show this video for the next 20 minutes, and of course we are not going to do that, you can see that this is a recurring pattern, that the reuse that they have in the different movies, across movies. And this recurs basically in all the filmography, more and more until Disney acquired Pixar. After, of course, it was a bit easier, but before that, it was a must, the reuse of the entire animation between one movie and the other movie. Now, you can watch this on YouTube, reuse Disney, you will find those videos. And that's how why I'm using this video today, because how did I do that? So basically, why did I do that? Well, they did it because imagine they need to sketch. Well, they have to define different sketches, and then they need to test these sketches. They need to test the animation, they need to put them together. Once they do it for one animation, then if they can reuse it, they can save a lot of time in the next animation. If they can reanimate the sketches and add it on top of the sketches and modify the sketches, they can save a lot of time. And this was a must, a necessity for them, because they had to release with almost a movie new every year. So they were thinking with this reuse mindset from the beginning. But how does it work? Well, the way they did it, it's probably based on clone and own, so copy and paste. So they have like a product, and the product A, let's say the first movie that you saw, they take the sketches of the product, they copy the sketches, the full animated sketches, they create a copy out of it. And then after they created the copy, they start to edit the copy, to modify the copy. So they start to add things to the copy, they start to change things to the topic or remove things to the copy. Now, the same things can be applied to that requirement specification, can be applied to a test plan, can be applied to a source code file. Okay, the same logic that Disney used for the movies can be applied to other type of assets and other type of industry and businesses. But which is the drawback here? Well, there are several ones actually. First, the product A was not intended to reuse from the beginning. So there are many things that may work, but the context of product B probably different. So what was working for product A may not work from product B. And if you find a defect in product B, then you need to see, will this defect also apply to product A? Yes or no? And you need to test it and check it. Now, of course, with two products here, it's quite easy to apply such approach. But imagine if you have many more products and you want to reuse across them. How you are going to do that with copy and paste and clone and all? In Disney probably was working because they were releasing a movie every year. So they didn't have parallel development, and the simplicity, it was quite obvious in comparison with complex engineering systems. But there are also other strategies, because reuse is just one aspect. Then you need to control the variability. Let's say you start now developing several variants of your product, and you want to control the reuse. You want to know what is common, what is variable across those products. Well, then you need to probably, what I'm seeing many times, Excel spreadsheets. No? So where you have, like, on the left side, you have the features, the capability, the functions, the requirements. On the upper side, you have the products, the variants, or the other way around. And you can see the requirement applies, does not apply to the specific variant or product. Sometimes I also seen this type of application, this type of usage called applicability matrix applied to requirement management system. So you have Doors Classic, and Doors Classic, you create a column, custom column, and there you have the attributes for a column for product, and then you say the requirement applies, does not apply. Which is the problem with this approach? That there is a lot of duplication of requirements, okay? Because you have to rewrite completely the requirements if there is a small variation and changes in the requirements. And still, if you want to implement a change, you have to go in through each requirement and each product and change the things manually. So again, it looks okay, it looks easy to start, but probably is not the most efficient, the most effective one, especially if you have complex product and more variability. Now, which is the problem with these two approaches? The key problem is that the system, so if you are doing systems engineering, probably you are working for a company that develop product with a certain level of complexity. So those products also have a certain level of technology embedded in it. And those products fulfill certain capabilities that are increasing along the years. So we have more and more increased capabilities, better improved capability of our system. But which is the problem? That the engineering tools that we use to develop such systems are not as advanced in many cases, and they don't has the system we develop. They don't have the same capability, the same level of capability. So like you are, building an aircraft, super advanced aircraft, with a PowerPoint or with a Word document. That's the case we are talking about. So, and there is a gap in many cases, and who is going to fill and bridge this gap? Well, the systems engineers are filling this gap. And we have to thank them, but is there a better way of doing that? Can we improve that? That's the question we would like to answer with model-based product line engineering. So, and that's why this leads us to the foundation of the book. So what is model-based product line engineering? Why it differs from clone and own, from copy and paste, from applicability matrices? Well, first, the idea is that we want to work with models, not fully complete with models, but as much as possible with models. Why? Because models are machine verifiable. Model is well defined, improve the quality and the verification also of the system that you develop, right? And they can allow early validation of your system. There is a lot of advantages of using models versus document. I'm not gonna now focus on this for this presentation. I think this is clear. And which is the problem as well, that if you don't have the right solution, today we have projects that are complex, people in multi-location. Today I had a customer discussion from your area earlier on today, and it's from the Nordics, and they told me that they have facility in different countries in Scandinavia, and then they have like a facility in Asia, and of course multi-location. The work share, it's a key thing. You have different technologies, and you have multiple variants. So out of it, you need to define multiple variants of your systems. Then you have different disciplines involved. You have software, geometry, you have ALM, PLM, you have performances, safety, and so on and so forth. And if you take the engineer's brain, the architect should know how the features goes together, how the capability of your system works together, what goes well together, what doesn't go well together. That's the history of the previous project. This engineer's brain, even if you take the smartest engineer in the room, he cannot catch up with such complexity. That's why many times the answer that I see is bringing more engineering brains. But if you bring more engineers, more brains, and you don't have the right solution to collaborate, what will happen is that they will create more perspective, and sometimes, in many cases, they will create more challenges. So this is, as I said, because human brains cannot keep up with such complexity. When you have complexity, variability, and you still rely on traditional engineering tools like Word, Excel, or disconnected silo solution. How can we deal with this complexity? How can we deal with this variability? So first, I want to make a recap here now. So I mentioned two variables that we have: complexity and variability. And if you develop products that are not complex, very low complexity, and almost no variability, then you can make it with a clone and own approach. Okay, it's not the best way to do that, but again, it will work if you have good engineers. But the moment you increase a bit the complexity and the variance, so then you need to bring probably you can bring the applicability matrix because you have more variants. So you have 5, 6 products, 5, 6 variants. And the complexity is a bit higher. So you cannot just deal with the specification, with the documentation. You need to have a requirement management system probably to manage the complexity with traceability. And then you can have these applicability matrices. No? But the moment your complexity gets on a higher level and your variability also gets on a higher level, these two approaches are not efficient anymore, not effective anymore. And so if you have a large set of requirements and you want to reuse them across product variants without complexity, if you have more than one engineering domain in scope, so if you have the requirements and the test cases, the requirements and the model, the requirement and the source codes, and you produce a large quantity of product variants, then probably, and if you are high in complexity and variability, model-based product engineering is for you and for your organization. But what is this about? Okay, so it's about bringing the model-based dimension. It means traceability, consistency, single source of truth, collaboration on the system level to manage complexity, and the product line engineering part. There's a systematic reuse, not clone and own, not copy and paste, not reuse by accident. Manage variation and variance, knowing where is the variability in your system, where is the commonality, and having a single source of variability. It means like I know I have variability defined for my system, and I know I'm going to implement this variability consistently in the requirements, in the test cases, in the source code, and the CAD, and so on and so forth. Now, one point that I always like to make, model-based system engineering has been probably one of the key disciplines in the latest 10, 15 years. There is one big challenge with model-based system engineering, that you cannot prove today the benefits in a quantitative way. One of the reasons is, even if I am MBSE expert, so I defend MBSE, I think it's a good practice. On the other hand, what is the problem, the challenge with MBSE? That imagine your organization is investing a lot of money in rolling out MBSE for a new project. They will do that, and there's a high learning curve, and there is a lot of investment to be done to learn and apply and tailor the solution to your organization, the method, the process, and then you start working productively, you start modeling, but then those models in many cases cannot be reused for the next projects. So it means that all this investment will be absorbed only by the first project. But if you bring product line engineering from the beginning, when you are starting your MBSE activity, then you can already build your models with reuse. So you can already embed the reuse of the models from the beginning. And you can return earlier on investment because you can reuse those models across the next projects that you will have. So that's the key thing. So model-based boost PLE because you bring consistency, you bring single source of truth, because you bring the machine verifiable models. And on the other end, product engineering boost model-based approach because it brings the reusability, the reuse of those models in a consistent way. Now, we didn't invent anything. So there are two standards. The first, the ISO 26550, that was the first standard that laid the foundation on PLE. And then in 2021, it came a new standard it's an evolution, it's a complementary standard. I would not say you just use the second one, the 26580. You should use the standard in combinations in order to have a good approach, a good application of the approach. The main difference is that the new standard introduced the concept of models. It's more, I would say, it's less generic, it's more straightforward, explain the concept of the factory, PLE factory, how does it work in steps, and most important things, introduce the concept of features. The previous standard does not have feature. Many people, many companies were saying, well, if I do clone and own, I'm still doing PLE. Now, if you do PLE, you need to do it feature-based. That's what the new standard says. Let's have a look what feature-based means. But before that, then we start to go into the implementation. Okay, how does it work when I have implemented? We start with what we call MBPLE paradigm. The paradigm, it's basically the approach, the key approach, the key steps that you need to perform on a PLE approach. First step, I define the feature models. What are those feature models? Well, these are feature trees, decision trees, better if represented them in models, as models. And in these trees, we define the variability and the commonalities. We tend to focus on the variability because the variation is what really matters for us, what creates cost, deviation, challenges. So that's where we capture the variability, and they are also called feature catalog or single source of truth for variability. Instead of using the Excel sheet, the spreadsheet, we use feature models. Then the second step is that, okay, with the feature model only, I can understand the variability of my project, of my system, but I cannot really reuse. How do I enable the reuse? I don't want to use clone and own. Well, the approach that we are going to have here is we are going to use these features to understand where is the variation in my requirements, where is the variation in my test cases, where is the variation. We are going to identify the common parts of our test cases, of our source code, of our requirements, and their variations. Where we are going to understand where are the variation point, the point where our assets, our requirements starts varying. And these points, we link them with the features. So we have the features model that will link it with those assets. We link it with the requirements asset, with the test cases, the source code, the CAD model, the MBSE models. And we do that because the feature model can now control the assets. They can filter the assets and can define what can be reused and what cannot be reused. So feature model define share asset superset. The share asset superset can be the model, the requirements, can be the test case repository, and we link them together. Now the third step is that now I select my feature. I select my configuration of features with rules, because the approach also needs to be supported by rules that allow you to have a valid selection. And once I select my feature configuration, then I will filter out only the parts of the asset that is specific for my configuration, is specific for my variants. Very different from clone and own approach, because a clone and own approach, it's basically I copy and change, and I don't have any overview of what is common, what is variable across series of projects. Now, with this approach, if you want to implement a change, a fix of a defect, we can do it on the product line. We can do it on the define share asset supersets, cascaded to all the variants, because we are doing that on the origin. That's just one of the many advantages of doing that. How does it look like? Now, of course, I use here variants. That's the tool that I use. Actually, it's the leading solution in the world for product line engineering. 95% of the customer worldwide use this solution. And we have here an example of a UAV, of a drone. You can see that we have a feature tree on the left that can also be represented as model as a diagram on the right. We also have the web-based version I'm using the client, but this is also web-based if you want. So here we define the variation, number of engines, 4, 6. If we have 6 engines, we require long distance battery. And the battery can be standard and long distance, but of course, you know, if you're gonna have the long distance battery, you need 6 engines. You have 2 different type of video compression format. You may have a strobe light or not, okay? Very simple example. Now, after we have captured the variability, we focus on the assets. So here we have a SysML v2 model, and we see that we have like parts and part definition. So we have the drone. The drone has 3 variations. One variation is the engine, number of engine, one is the battery, and one is the body, because the body can have a payload, small payload or large payload. Now, this is not the feature model, right? This is the architecture model. And this type of variation that you have here, you can also have it on the requirements. You can also have it on the test cases. If you just define the variation in your MBSE models and in SML v2 models, and you don't have any reference of the variability somewhere else in a feature model, then each and every time you define the variability in your assets, you need to redo it from 0. And at the end of the day, you need to be sure that all the pieces match together. That will be a nightmare. That's why we need a single source of truth for the variability. That's our feature model. So we're going to link that feature model with these architecture models. And then we are going to select the configuration. So we can have a UAV for delivery. We can have a UAV for inspections. Once we'll have 4 engines, once we'll have 6 engines. You know, it's like a car configurator, right? And then the results will be that we will have an instance, 100% of my drone with 6 engine, with the power battery, and with a type of battery, and with a large payload attached. And that's how my architecture will be for that specific configuration that I'm supporting. Consider this like a car configurator, but instead of configuring the final car with the parts, the physical parts, the color and so on, you are configuring the engineering assets that you need to build the car, that you need to build the airplane, that you need to build the train. That is not, in a nutshell, the approach of PLE, what is described in the standard. And as I said, it's a discipline that has over 25 years. And it started in the software domain, and then it extended now in system domain, mechatronics. Now, there is no presentation nowadays, and also our book, that does not include AI. And that's why in the book, we decided also to explore some use cases how artificial intelligence can support model-based product line engineering. So, and we wanted to define that as AI as a PLE expert. Now you can use AI as a product line engineering expert. The use cases that we cover was very simple, and this you also can find in the book. It's how to create a feature model from an existing specification of a legacy product. So you have a legacy product, you have a lot of documentation, how you can from there create a feature model and a variability model. And now how you can add new features to your product line, and how you can identify the requirements that are impacted by this new feature. Here I'm using Watson X from IBM. At that time I was working for IBM, and pure variance. Here you can see now a simple example. So we have like a PDF file, but this could also be done directly from a requirement management system. Now for simplicity, we use a PDF file here. We upload our PDF. And after we upload the PDF, and this is a Watson platform from IBM, we have now the PDF, you can see, with different requirements, and there are some variability in this requirement that we don't know. We need to extract. So we extract, and now we have extracted the requirements, and they will be extracted as a table. The table has been already set to have like features and variation. Now this table will be extracted as an Excel spreadsheet, because it could also be integrated inside the tool. This is just to demonstrate the use cases. So now we go into pure variance, we import the Excel sheet, and we will see now that what will be created, it's basically are those features that are being extracted by the drone. And now I'm going basically to name it. So I will give them a name. And of this drone that is doing short to ship delivery. Now I'm seeing here I have very simple feature model created and with some feature. So now this variability is just the starting point of my legacy that I have. And now I'm going to add new features. So I ask the intelligence to add new features, like to support payload up to 15 kilos, and also to provide the requirements that are impacted by that. And then I'm also having another requirement that is how to provide more trips, 4 round trips capacity instead of just 2 round trips capacity. And I'm adding these new requirements. So I'm updating now, and it's telling me which requirements are impacted by these new features. Now, of course, this can also be done inside the requirement management system directly. This is just for demonstrations. And in the book, we didn't want to show any specific requirement management system. And now we have here the new features and the requirements impacted. We have updated our feature model here. So the table looks much bigger than before. And now we are going to re-export and re-import the Excel spreadsheet inside the feature model. And after we do that, we can see now that from the same feature model, we are going to import the new features. And we are going to see bigger feature model with more variability in it. So here we are going to import it. I'm going to speed up this part. And it will update the features. And you will see now that we have the feature model, and we will have more features than before. We can open this feature. We can see that each feature has alternatives and sub-feature in it. So this is just an example, simple example, how AI can help extract the information from a legacy artifacts and start helping you to build your product line. And of course, after we have discussed the implementation, I want to quickly go on the adoption, and then I want to leave some time for questions. So in order to adopt, you need a business case. Which is the key business case here is that if you have at least 3 products to be developed, then it makes sense to apply model-based product line engineering. This is based on our experience, based on the companies we have interviewed, based on the cases we have. So it means that after the 3rd product, as you can see, you will start to see a break-even and return of investment. Now, the good news, if you apply PLE against clone and own and copy-paste. The good news here is that you don't need to have an investment. The investment doesn't need to be done all in the beginning, but you can share the development investment of your product line along the years. Otherwise, if you do everything on the beginning, you will have a big pressure from your management because you spend a lot of budget from the first year. Second, you will have a big lead penalty for the first product. That's why it's good to spread, we recommend to spread the investment along the years and then to build the delta of your product line along the time with prioritization. And the other one shows how MBPLE is superior as approach in comparison with, for a given number of numbers, you can see the saving if you have just clone and own, model-based, modeling and simulation, and MBPLE. On the long run, if you do it consistently, you can save a lot. And MBPLE is not for everybody, as I mentioned before. It's for those companies that are on the upper right quadrant, that have high complexity, high variability. How do you get there? Also, you can get there in different ways. So you can start a document-based for a single system. And then since your complexity increase, you will slowly move to MBSE. And then from MBSE, you can slowly move to MBSE. First, you will have mainly requirements and you will add some models until you reach a model-centric approach. Now, if you start from document-based and instead of having increase of complexity, you see increase of variability first, then you will start to adapt reuse practices to your documentation to your system development, like the applicability matrix, like Lune and On, until you reach PLE. Now, from that 2 points, from these 2 quadrants, then if you start to have either increase, you are the high complexity, you start to have more variability, then you will slowly introduce model-based product line engineering with first focus on MBSC and embedding PLE in your MBSC assets first and then in the others. And the other way around. First, you will treat MBSC as any type of other model assets, and then soon the model will become central and more important in your design and development. So these are just different ways, different patterns that different company, also Airbus follow one pattern, Thales follow another patterns, RTX another one as well. So depending on the company, they follow different patterns, but at the end they reach the upper quadrant for different reasons, for different maturity levels. Now, we strongly recommend to have a framework to support your MBPLE. That's what we talk about in the book, and we spend a lot of time in explaining how the framework should look like. In a nutshell, you should have processes, so implement the standard that I mentioned, and be sure that these standards are adapted to your organization, to your system engineering practices, also the ISO 15288, how can include PLE. Then the methods, so you need to understand how you are going to define the variability in your requirements, in your models, how you're going to build your feature models, how those are going to look like. But then we don't want to speak tools language. We want to have ontology, meta model, information model to be tool independent and to be able to describe the solution and exchange information without relying on a single specific tool. Then, of course, you need a tool chain. We don't talk about PLE tool only, pure variants or other tools. We talk also about the entire tool chain because, as you have seen, if you have just the PLE tool and you don't have the assets to link with, you cannot reuse. So it's a tool chain matter here. And last but not least, technology, it's easy, people are art. So you need organizational change in place, and you need organizational structure. You need to invest in with your champions in the organization. Otherwise, it will be difficult to fly. If you want to know more, of course, you can buy the book. And after I will share also a way to get 20% discount. But there is also the PLE International Working Group. We are very active. I'm leading the PLE working group at INCOSE together with Roland Darbin. In the last year, we have seen an increase of 90% in membership. And we are doing regular webinars. And at the IS 2025 in Ottawa, we have a full program of activity, presentation, tutorial, panels, meeting, dinner, all focused on PLE. Please, if you want to know more about it, don't hesitate to contact me. And you will find all the information in the INCOSE IS program and in the INCOSE webpage. Register to the PLE working group if you are interested about it. Now, to conclude the industrial cases. We have 2 industrial cases selected here out of the 5 for a matter of time. The first is the Airbus. And Airbus, because I work for Airbus, Guillermo worked for Airbus, team supported Airbus. It's definitely Airbus, I can say, is the origin of this MBPLE story, because where it got concrete, and other companies like MBDA got inspiration by Airbus, Belimo also a bit by Airbus. So Thales, Airbus got inspired by Thales. Guillermo was working for Thales before. There is a PLE connection here, as you can see. And Airbus is important because the variability in Airbus is everywhere, and you need to manage it. So you have variability at the product level, the aircraft, at the industrial system, the final assembly line, the services. Then you have, imagine like you develop a plane, you don't take in consideration your final assembly line, then you go into the final assembly line and you cannot reuse. So you need to then to build the final assembly line on purpose for support the specific airplane model that you have. So it's important to consider the variability also of the services that you are providing with the product. Then we have different hierarchy levels. So we have the product, the aircraft, we have the cabin, we have the system inside the cabin, the monuments, we have the components, and you have to understand the variability from the higher level, how is it cascading as impacting the other levels. We have different level of abstractions. We have the operations of the plane. How do I refurnish my plane? How do I do the cargo loading in my plane? How do I do the e-taxi, the pushback? And this will have variability depending on the model, depending on the circumstances. We have functional variability in the function, in the logical part, how these functions are allocated, and in the physical parts. And last but not least, we have variability, maturity in the development. At the beginning of your development, you don't have all the information available. You probably know the seating configuration, maybe you know the twin aisle, is a single aisle, you know the performances that needs to achieve. But the more you go in your development life cycle, you will discover more variability. You will add your variability during your journey. So you need a solution to manage all of this. You need an holistic approach, because all these things are described with assets, engineering assets, that you want to reuse, that you want to control the variability, not just for Airbus, but also for the suppliers of Airbus. The other case is Thales, and here is a bit different. So it's ground master radars. In nutshell, they had a big problem. They have 3,000 parameters across 40 large software, not just software, mechatronics components. Imagine each parameter has at least 2, 3 variables, even 4 sometimes, of variability. We end up within 8 and 9,000 possibilities, only of the parameters. Now imagine those parameters are in the requirements, are in the test cases, are in the models, and you need to update these parameters for new variants that you're going to create. How long it will take? Well, Thales knows how long it will take. For one component, it was taking around 120 hours to update the parameters. Now they pass from 120 hours to 4 hours, because now with the feature approach, they just can apply the feature. The feature will have embed parameters in it and will cascade, inject the parameters in all those assets that have them. So this is an achievement, very simple case, just an example how Thales managed to reuse, improve the reusability and the variability management of their system. Just one of the many examples we have in the book. To conclude, because I want to take some questions, what are the key ways of our book, of this presentation? First, I encourage everybody to look at the 26580, because we didn't invent anything. It's a lighthouse standard for MBPLE, for product line engineering. And for feature-based product line engineering, please have a look at that. Don't reinvent the wheel, because many people, many experts work on that. And many companies, as you see, are applying it. Now, the MBPLE factory is possible. The approach that you saw, the mechanism, it works. It works for requirements, it works for models, it works for test cases, for CAD. Just prioritize your engineering assets, prioritize where you have more pains. Last but not least, the tools must enable the digital continuity. I'm a tools vendor right now, so I have to admit that still we are not there with the ALM, PLM integration, and PLE is a topic that will influence both ALM and PLM domains, because the variability needs to be consistent in most of the case between your ALM world and PLM world. So we need more integration, more digital continuity of tools that support that. And with that, I finish my presentation, and I will be happy to answer your questions.
Thank you so much, Marco. And I'll keep your screen up open, so if somebody has a question that you want to show something. So anybody, you can certainly, now I think we don't have anything in the chat, so just feel free to unmute, or if you want to write in the chat, that's good. That's fine too. While we wait maybe for somebody, is there any silver bullet for how to define the variation points using model-based, or is that up to sort of somebody who has a good feeling for? But can you get any help in that step of the process?
Well, the variation part, it's not the most difficult part. The problem that I see, the challenge that you have, is that you have hierarchies in systems, right? And if you define a variation at high level, you want this variation to cascade to the lower level, because you don't want to define each and every time the same variation. Today, the solutions, even an MBSE solution or requirement solution, don't cascade these variation points. This is one of the problem we had at Airbus. This would have been like a silver bullet, because if you make the model understand how this variation should cascade, then you will save a lot of time in defining the variation in all the levels. So this, for me at least, was a good takeaway. We built some automation at Airbus at that time to cascade this variation. Let's say if the block has a variation, the part below will have a variation. This type of automation I'm talking about. Yeah, and also depending on the assets, you will have different variation, right? So in requirements, it's quite easy. In model, is a bit more difficult because you have the constraint of the language. Even if XML v2 has some advantages. In source code, it's quite easy, I would say, but you have other challenges there. I think there are some questions I see.
Yep. Yep. So basically what you said is very good to have also your system modeled, so to help you out on finding that relationship or cascading of variations points. Yeah. Good. Yes, we have a question from Jakob Schultz. I'll read it out in case we don't get it in the recording. We often struggle to discuss the definition of feature. In my humble opinion, it should be a customer relevant characteristic. In your PowerPoint, I saw the number of engines as a feature. To me, the range, thrust, power, etc. would be a feature, and the number of engines a solution. Or did I get it wrong?
You didn't get it wrong. It's just that we are flexible with feature. Okay, so where I would say some companies are more mechanical, electrically driven, and for them it's very difficult to abstract features. Others, we have already a functional breakdown structure, key parameter, performance listed, so for them it would be easier to apply the feature on a higher level. We are not like dogmatic or let's say strict in that. To say whatever for you matters, whatever brings a variation, please have it. Sometimes in your feature model. Sometimes we also distinguish in high level external variability, internal variability. So the external variability is what you expose to the customers. And you can split also the feature model in these two parts, and the internal variability, what is not exposed to the customer, but creates problem internally when you implement it. So it really depends on the approach you're going to follow. And you can use both, higher level description of features and also lower level description of features.
All right, thank you.
Yeah.
Thank you, Jakob. And Johan Tegler has some questions regarding examples from the automotive sector, cars, trucks, or even smartphones or telecom.
Yeah. So now, probably we'll make a new edition of the book because we didn't have space for other cases. This book is more focused on mainly FNDA, so aviation and defense. Also, it's the most mature part where we see, but of course, automotive. I work together with the biggest automotive in my role, biggest automotive company in the world. And I can tell you that all the biggest OEM, or at least 90% of them, use PLE. And I'm working with them. Some names I can mention: Ford, Stellantis, BMW, just to give you Volkswagen, but also the suppliers, Bosch, Continental, ZF, just to give you an idea. Yes, we have such approach, and it's not in the book, but I support customers in this other industry. And a smartphone is coming. We have medical devices. We have telco, not yet. More the satellite part, yes, but the telco itself, the infrastructure, no. So far, I didn't see it. I saw nuclear plants. So product line applied to nuclear plants, to nuclear reactors, actually, not plants. So it can be applied everywhere. It just needs to depend to which level, to which extent, but we have several cases. And by the way, if you want to know more specifically, I have a demonstration and best practice for each industrial verticals. You can come back to me and we can discuss that.
Okay, well, time is running, but maybe Marcus has been trying to get his hand up here. So unmute and pose that question, and then maybe we can take the from Christopher and Björn a bit after I finalize the recording here. So yeah.
All right, thank you. I was trying to find a raise hand, and I realized I can actually try to raise my hand physically, but no one was looking, I think. So I wrote in the chat. Anyway, I'm from the automotive industry, tier 1 supplier. In my environment, there's a lot of talk about lean product development. And one of the key enablers for lean is to reuse knowledge. So in that community, they talk about knowledge-based development and knowledge value stream, etc. So do you have an experience of, because for me, this is the same thing. Feature-based product engineering is basically just a modern way of doing what they already try to do. But if I start talking feature-based product engineering with people who know that stuff, they don't understand what I'm saying. So I'm trying to re-express the concepts using their language from lean and knowledge-based development and so on. Do you have an experience for how that kind of approach can be used as a strategy to enable more interest and understanding of this topic?
If I understood right, your question is how you can use PLE to present lean product development. So I didn't get probably the connection between the two things.
Okay, it's fine. So I think this is kind of an invention that I found commonality between the different domains, and they use completely different vocabulary and books and everything. But for me, it's apparent that it's the same. So if you haven't heard about knowledge-based development and this lean knowledge value
no, I
stream,
heard
maybe
about it. I heard about
okay.
it. I heard about it. It's just
But
that
you haven't made a connection between your, yeah.
It can be combined. Like if you do lean product development,
it's the same. That's the thing. For me, it's the same. It's just a way to do it that's using digital tools to their fullest advantage.
Yeah, it's not really the same. It's a combination of, so you can combine that with PLE, but it's not really the same. So that's at least what I can tell you. Like model-based development, you can do PLE in model-based development, but if you do model-based development, you are not doing PLE. Okay, that's the idea. No, we can discuss this if you want also on, we can exchange more on this topic because, you know, I would be happy to also see your point of view on that and maybe understand a bit better what you mean with that, because I think probably I don't get the, yeah. So maybe, you know, feel free to contact me. I'm happy to exchange.
I will. Thank you.
Please.
Okay, I think we'll do this. I'm gonna end the seminar, but maybe if you are able, Marco, to hang on a little bit, then you can respond to Björn and Christopher's questions. But I just wanted to go ahead and because we are out of time, to close this one. See if I can
reply quickly.
Yeah, while I'm changing
if you want.
screen. Yeah. Oh,
so software practices where the causal issue that lead to the development in software. Well, in software you have like several things, and one thing I can mention is that what you cannot reuse with PLE, it's the test result, because after you do the transformation of your PLE, you have your variant and you transform the source code. In order to have you can reuse the test case, but you cannot reuse the test result, because the test result can only occur after you have transformed your variant, you have your final piece of code, configure your baseline, you're going to test it. And after you have tested it, you get your test results specific for the system under test, for those variables, for the environment, for the specific baseline of code. And you cannot have this before you perform the transformation on a PLE level. So you can reuse test cases in software, you can reuse code, but you cannot reuse with PLE the test results itself. You need to apply other practices to do that. This is probably one of the challenges that I see and that PLE is not able to solve yet alone, okay? And the language that we use, there are several languages that are used. There's no standard language for variability. There were attempts in the past to develop a common variability language, a CVL. You can search for it. Most of the tools today are based on FODA, that is a feature-oriented approach. And Czarnecki was one of the guys that invented and developed this cardinality-based feature modeling. But there is not a standard language yet for feature modeling. We have also attempt for exchange language for variability, like VL, variability exchange language, but still is not a standard yet. So the solution are still pretty much proprietary today. And that's a very big miss, unfortunately, but it's very difficult to bring and convince the existing provider of the solution to align on one specific language, mainly for IP reason, like that's the main issue. Yeah.
All right, I think those are the questions we had, and I guess you're able to take emails or outside
Please.
this one. Yeah, and I'd just like to inform everyone that on the Swedish Encode Society we'll have this presentation available. Probably takes after the weekend, and there will be also information about next webinars, which would be actually a report of this event, which will be coming up. And as Marco said, I mean, why not join this one and then actually practice some PLE for the dinner even? I was going to ask what variation points you have for that dinner, so accommodate all kinds of tastes and so on. But so this is the big event, of course, happening. A smaller event that's happening in the fall is the Nordic Engineering Tour. We just completed the first one, which is one of these events where we collaborate again between the Nordic chapters, and there will be a second one in September, reaching at least Stockholm and Oslo. So you can read more about that coming up. So with that, on behalf of the Swedish chapter, behalf of the Norwegian chapters and Danish chapter, Jens Christian, we'd like to thank you, Marco, for setting this up or presenting it. And also you all online, thank you for joining. We had a good crowd this time with 74 people all in all. A topic that seems to be very hot. So we're looking forward
Happy to hear that.
Of the book as well.
Tom, I will send to you the slides, and I will send to you an email that can be used to order the book with a 20% discount. Okay?
Great. Thank you so much. And with
Thank you for inviting me.
Yeah, and happy midsummer to everyone. So see you soon again.
Thanks a lot. Thank you.
Thank you.
Thank you all. Thank you, Marco.
Bye-bye.
Thanks so much. Thank you. Bye-bye.
Bye.
I'll stop the recording. There. Go.